Imagine a country where water is worth more than gold, a land where the scorching sun beats down on endless seas of sand, and rainfall is so rare that the desert seems almost eternal. Now imagine that this country, Saudi Arabia, has found a way to bring life-giving water across hundreds of miles of inhospitable desert through a complex network of pipelines to sustain millions of people. How is this even possible? How do engineers make water appear where there seems to be none? Today, we take you behind the scenes of one of the most remarkable engineering achievements in the modern world, the water pipelines of Saudi Arabia. Saudi Arabia is one of the driest countries on Earth. In some regions, annual rainfall measures less than 100 millimeters. Cities grow rapidly, populations rise, and industries demand more water than nature can supply. Agriculture, which feeds the nation, needs water, and urban centers require millions of liters daily for households and infrastructure. In a place where rivers are almost non-existent and natural freshwater sources are scarce, the solution had to be ambitious. Desalination plants, underground reservoirs, and an extensive pipeline network became the lifelines of the country. But creating such a system was no small feat. It required vision, innovation, and absolute precision. The first step in this monumental task is planning. Before a single pipe is laid, engineers and planners spend years analyzing maps, satellite images, and geological data. The desert is not just sand, it's an intricate landscape of shifting dunes, rocky plains, and underground aquifers. Every meter of soil must be surveyed to determine how the pipeline will be laid. Engineers study topography to ensure that water can flow efficiently, minimizing the energy needed to pump it across vast distances. They also consider soil composition, as certain types of desert terrain can shift unexpectedly, risking cracks or breaks in the pipeline. Environmental studies are conducted to minimize the ecological impact. Permissions from local authorities and long-term sustainability plans must be secured years in advance. It is a delicate balance between engineering precision, environmental stewardship, and practical feasibility. Once the planning is complete, attention turns to materials and technology. The pipelines are made from high-strength steel, capable of withstanding not only immense pressure, but also the harsh desert conditions. Corrosion, extreme heat, and sand abrasion are constant threats. Pumps, some of which are among the largest in the world, push water over hundreds of kilometers, maintaining pressure and ensuring consistent flow. Advanced sensors are embedded throughout the network to monitor water pressure, flow rate, and temperature in real time. In coastal areas, desalination plants transform seawater into clean drinking water. Reverse osmosis membranes filter out salt and impurities, while chemical treatments ensure safety and quality. Every component, from steel pipes to microchips and sensors, plays a critical role in making this life-sustaining system work. The construction phase is where theory becomes reality, and the desert begins to change under the weight of human ingenuity. Trenches are dug across shifting sands and rocky terrain. Massive steel pipes, often weighing several tons each, are welded and carefully lowered into place. Pump stations are strategically built every few dozen kilometers, functioning like heartbeats along the pipeline, pushing water steadily forward. Extreme heat and blowing sand make every day a battle. Construction crews work with precision under conditions that would test the limits of any engineer. And just when one might think the process is straightforward, unexpected challenges arise. Sudden sandstorms, equipment failures, or shifting terrain can halt progress and require rapid problem solving. The desert is an unforgiving teacher, and the engineers must adapt constantly. Once installed, the pipeline is more than a set of pipes. It becomes a living system, continuously monitored and maintained. Water moves through a combination of pumps, gravity-fed channels, and pressure-regulated valves. Coastal desalination plants remove salt and impurities, while sensors feed information to central control centers where engineers monitor the network 24/7. If pressure drops unexpectedly, automated systems adjust flow rates to prevent disruptions. Chemists analyze water samples daily to ensure the quality meets strict health standards. It is a symphony of engineering, technology, and science, all working seamlessly to bring water to places where it has never naturally existed. Quality assurance is as important as the construction itself. Ultrasonic sensors scan for cracks, drones inspect remote sections of the pipeline, and engineers conduct stress tests on every joint and valve. Even a small leak could affect millions of people, so meticulous attention is given to every detail. The system is continuously optimized, from adjusting pump speeds to upgrading monitoring software. Engineers do not simply install the pipelines and walk away. They are alive, constantly adapting to the desert and the demands of a growing nation. The impact of these pipelines is profound. Cities once limited by water scarcity can expand and thrive. Farmlands that would have been barren now grow crops that feed millions. Industries, from petrochemicals to food processing, have the resources they need to operate efficiently. Water pipelines have reshaped the economic and social landscape of Saudi Arabia. Beyond utility, they are a source of hope, a symbol of what human ingenuity can achieve even in the harshest environments. The pipelines are sometimes called the veins of life, a fitting metaphor for a system that sustains a nation. Beyond the technical and economic aspects, there is also a human story. For many communities, access to water transforms daily life. Children can attend school without spending hours fetching water. Families have reliable sources for drinking, cooking, and hygiene. Local economies benefit, and the quality of life improves. These pipelines are more than infrastructure. They are instruments of social change, quietly but profoundly improving lives every day. The pipelines also represent an ongoing commitment to innovation. Saudi Arabia continues to invest in smarter monitoring systems, energy-efficient pumps, and sustainable water management practices. Engineers experiment with new materials that last longer under extreme conditions, and new desalination methods promise to reduce energy consumption. The network is not static. It evolves with technology and the needs of the population. This is a testament to long-term planning and the vision of a nation determined to overcome its natural limitations. Imagine the scale. Hundreds of kilometers of steel stretching across desert plains, thousands of pumps operating in synchronization, sensors and computers monitoring every drop, and teams of engineers working tirelessly to keep it all running. This is not just a pipeline, it is a lifeline, a marvel of engineering, a blend of science, logistics, and sheer determination. And while it might seem like a simple utility, it represents centuries of human problem solving adapted to one of the most extreme environments on Earth.